x to the a over b power is equal to the b root of x to the a power. Okay, now where does this come from? I am going to show you. I thought it would upload to this, but it did not. So I'll just have to write it. You can, just so you know, you have access to your textbook online. I think you guys know that, but just to remind you. And that's where I'm going to go right now. I'm going to go into HMH. And so when you want to look at your textbook, you would go to Student Resources. And then this is the entire textbook. And right now we are in Unit 6, Module 14, Lesson 14.1. And so if you click on that, you can get the student edition right here. And you can always go through and read this to help you understand anything. We covered this when you raise something to 0 power equals 1. When you raise something to a negative power, you actually do a reciprocal here, and then that becomes a positive power. This is where we were on Tuesday. The nth root of a is equal to a to the 1 over n power. And now we're looking at when a to the m over n power equals a to the 1 over n times m. So you can kind of derive this formula that I am sharing with you in the Pear Deck from breaking apart m over n as 1 over n times m, and then using the rule we have for a to the 1 over n power to rewrite it as n to the square root of a, and that's all raised to the m power. Now if you break it up the other way, where you have a to the m power and 1 over n out here, then a to the m power becomes the entire radicand for the nth root. So you can write it either way. Either way is correct. And I do want to add that to your slide here. So I'm going to get the pencil tool. And so if we start with a, the m over n, then we can rewrite that as a to the 1 over n times m. Okay, and then if I put parentheses here, which I'm allowed to do, this by the old rule is the nth root of a. And we're raising that all to the m power. Okay, now we can write it this way or you can write it this way, but they do mean the same thing. And so we're going to go through these examples together. So let's see. I have 3 of you already on this that are writing on it so far. Okay, but we're going to do this together. Don't put the parentheses with the answer be wrong. Nope, it wouldn't. So these are both okay. So you can even write it as, it's kind of like what it looks up here, but instead of m and n, they're using a and b. So the nth root of a, if the m is inside next to the a, that's okay, or it could be out here. They're both correct. All right, but the parentheses kind of help you see what's happening, but they don't have to be there. You can drop them. So here, for example, 2 says simplify expressions of fractional exponents. We have 27 to the 2/3 power. All right, so the rule here is the definition of a to the m over n is I take the numerator of the fractional exponent, which in this case is m, which is 2, and that becomes my exponent out here. All right, so this number here went there. And then the denominator of the fraction becomes the index. All right, they're kind of terrible arrows, but you can kind of see what I'm doing. So the numerator comes outside and the denominator goes here. And it's based off of what we were doing before. But now, you know, our numerator is not 1 anymore. So this is how this would work. But if our numerator was 1, it would be the same thing, because anything raised to the first power is itself. You just don't typically write something raised to the first power. And so once you use the definition of this right here, or this, however you want to consider it, just rewriting your power as a radical expression, then you rewrite the radicand as a power. So the radicand is 27, and 27 is the same thing as 3 times 3 times 3. Okay, and the reason we want to try to rewrite it as something to the third power is because my index is 3. So when the index and the power inside the square root match, it's like they're inverse operations and they cancel each other out. And so we're just left with 3, and then this 2 is still here. So 3 squared is 9. All right. So we'll do another one together here. 25 to the 3/2 power. So using the definition of a to the m over n, we're going to take our exponent, right? And it's going to, ooh, wrong tool, pencil. We're going to take our exponent, and it's going to go in this box. Okay. And then our index would come right here. Now, whenever the index is 2, you actually don't have to write it, but you can write it. It's not wrong to write it. You could put a 2 here as a huge 2. Let me try and make that smaller. Yeah, it's a little more appropriate in size. Okay, so what's going to go in this box right here? What number goes here where this purple arrow is pointing? Let me see what you guys are coming up with. No. Let's go to list view. Okay, so this person has a 3 right here, and that is correct. This person hasn't written very much yet. This is my slide. So if you're using the pencil tool, remember you can resize it all the way over to the left right here and make it any size you want. You're going to want the smallest size if you're trying to write on your slide. Otherwise, it's going to come out like that. 3. Yeah, a 3 here and a 2 here. That's good. 3. 3. Again, resize your tool so you can read that, because that, I mean, I know it's a 3 because it's supposed to be a 3, but otherwise it's kind of hard. Here's a 3. That's right. So that is what we're doing. We're going to put a 3 right here. Okay, so that's just using the definition of a to the m over n. We did that. Now that we have this, we're going to then rewrite the radicand as a power. My radicand is the number underneath the radical sign. And so my radicand here is 25. And my index is 2, so I'm trying to rewrite 25 as a power of 2. 25 is equal to 5 times 5. Okay, so since 25 is equal to 5 times 5, what am I going to put in these boxes? What am I going to put in these 3 boxes here? Again, you don't have to have this little 2 here, but you can totally write it if you want, right? We still have this 3 right here that hasn't changed. I'm just rewriting what we had from the previous problem. But now I want to take 25 and rewrite it as a power. Okay, and since there's an index of 2 here, I want a 2 here so that they can cancel out. So what goes in this box? What number goes here? So let's see what we're coming up with. 5, 5, 5. Yes, so to the 10 of you that are participating, it is 5. You're right. I can see some of you are putting that in the chat as well. Okay, so we are going to put 5 there. And now I've done the second step. definition of the blank root. What does that even mean? What kind of root is this? What word can go here? Definition of what root? Up here, they wrote definition of cube root, right? Because there was a little 3 as the index. Here I have a 2 as the index. So what kind of root is this? Yeah, Mauricio has it. Square. Square. It's a square root. So we're just going to type the word square right here. Okay, so it's a square root. And the definition of that is that since I'm taking the second root of something that's squared, they cancel each other out like inverse operations, and I'm just left with the 5, and I take that 3 that was out here and it comes here. All right, and then we have now done this step. And so the last thing here, what is our answer? What is 5 to the 3rd power? That does not mean 5 times 3. 5 to the 3rd power 5 times 5 times 5. That's what we're doing here. Equals, there we go. All right, let me move that so you can actually see it. So 5 to the 3rd power means 5 times 5 times 5. The 3 tells me 3 copies of 5. And you guys are putting not 5 plus 5 plus 5, but 3 times. Okay, you can use the little like asterisk or an X, or you can go back and put dots. Don't use the plus sign though. 125. 125. Mauricio says 125. Yeah, it's 125. So that's what we're going to put in that last box is 125. Okay. Now, some of you guys on Tuesday, you went ahead into Delta Math and you tried the ones that we hadn't even learned yet and you were able to pass it. And that's cool. I did leave these slides open that you could go forward on them. That assignment in Delta Math from Tuesday. Let me go find it. So I want to show you. So where is it? I gotta do that. Okay, so on Tuesday, we did number 9, Delta Math, simplified fractional exponents. We had only covered how to do half of these so far. So now you kind of know how to do the other half. There's still some that are a little bit different that I could go over with you. But we have so much stuff today going on that what I did is, if you look at this assignment, I changed the due date. So if you have it done, fantastic, but I pushed it back to the 23rd. So maybe try it over a break so you don't forget how to do this stuff. And then when we come back, it'll be due the Tuesday when we come back. So if you did it, awesome. If you haven't, don't stress about that right now. I just pushed that one back because we have so many other things going on today. Last slide here that we're going to do. I have so many windows open. I'm trying to manage all these windows and it cracks me up because it's like, all right. So I will put you on student paste. And I want you to go to the last slide, slide 8. Okay, slide 8. And I want you to try slide 8. Maybe like 3 minutes and then we'll go over it. Okay. Let's use this music. You guys are trying slide 8. Another minute. Do as much as you can. I'm gonna write the rule down for you so you have the rule. Okay, so before I look at what we did, I'm just going to put the rule on here. So a to the m over n power, you put a, the base, as your radicand, and then these two numbers would go in different places. So the denominator becomes the index, and the numerator becomes the power. Now you could put the power out here. You could also put it inside, but the way I've been showing you is outside, so I'm going to leave it on the outside. But it does work out either way. Like I said, these exponent rules, I don't know how far you may have got with them in 8th grade, but there are a lot of them that, you know, just kind of show up. They're like little tricks you can remember. I don't really like having to memorize tricks. I rather just work it out and figure it out by writing out. I don't know exactly what I'm trying to say, but I don't like memorizing stuff in math. That's why I like math, is because you can always figure it out as you go. So if you're not sure, there's different ways to go about it. It might be a longer route, okay, but you don't always have to use the shortcuts. Okay, anyhow, so let's see what you guys came up with here. And so for this first one, this looks good over here on the left. So we did put the 5, you know, 5 out here as the index. 32 became the base, and 3 became the numerator. And then we changed 32 to a power of 5 to match the index. Awesome. So the 5th root of something to the 5th power is just that thing, the radicand on its own. And then it's cubed and it's 8. This is perfect. I don't have to do anything. This is beautiful. Love it. Nice job. Hi. And so for the other one, let's see here. Did anyone get to the other one? Where's mine? Okay, let's see. Let's see how they did on this other one, because this person did it too. And so 4 to the 5/2 power. And so 2 is your denominator, becomes your index. You usually don't write the index, and you don't have to. So it's the square root of 4 to the 5th power. You should put, well, no, they did it. They're fine. Okay, so 2 squared becomes 2 to the 5th power, and that's 32. And over here, 4 to the 3/2 power, square root of 4. That's cubed. That's perfect, right? Again, when 2 is your denominator, it's your index becomes 2, and you don't usually write it, but you can write it if you wanted to. 4 is the same as 2 squared, so it's 2 to the 3rd power. This is really nice. 32 and 8. So 32 minus 8, and it's 24. I don't have to write anything. This is actually nicer than what I could do, because I'm not typing. I don't have the patience to type. I just try to like write it out. So we're going to go with, these are our solutions. All right. Nice job, mystery person that wrote hi. Okay. Oh, Mauricio says thanks. So I'm wondering if it's Mauricio. So this is